In this part of the experiment, we're going to look at what happens when you do an extraction with quinizarin. This is a solution of quinizarin and ethyl acetate. We're going to take 10 mils of our solution of quinizarin and ethyl acetate, and we're going to add it to the separatory funnel. After adding it to the separatory funnel, we're now going to add 10 mils of water. And when we shake our separatory funnel, and allow the layers to separate, we're going to see that there's absolutely no solubility of this quinizarin solution in water. We can see that the layers are remaining completely unseparated. It's almost a completely colorless layer with only the slightest tinge of orange. Once the layers have finished separating, we're going to drain our separatory funnel. Now what we're going to do is we're going to see what happens instead if we use 5% sodium hydroxide. In the last lab, you looked at the solubility in 5% sodium hydroxide. And we're going to add first 10 mils. Wait, we see something very dramatic happening. And now we're going to add 20 mils of 5% sodium hydroxide. Now what's going to happen when we shake our separatory funnel to make sure everything is mixed, and we're going to allow our layers to separate. I'm going to add 10 more mils of ethyl acetate to allow the layer to separate out more cleanly. You can now see where you have what's called an emulsion between the ethyl acetate and the water. One way to break up an emulsion is to add more solvent. Another way to break up an emulsion is to add your glass rod and swirl it around. Okay. Now that we've done this, we're going to want to drain our aqueous layer into our beaker. We see that this is a bright purple solution, and the small amount that is left is yellow. We're going to do what we learned in the previous experiment, that we are going to want to take a second extraction in order to fully extract the material, because we still see a small amount of orange in the ethyl acetate. So we're going to add 10 more mils of 5% sodium hydroxide. And now you can see that we have reduced the amount of color in the organic layer. You can see that the aqueous layer still has an intense color. That second extraction was very much worthwhile. Now, have we permanently changed the organic molecule we're trying to isolate? Here we have our beaker that contains our purple compound. Now what we're going to do is we're going to add 3 molar HCl. So we've added base. Now what happens when we add acid back into the solution? We're going to start by adding 10 mils, and we're going to swirl, and we see that we have an immediate color change back to the orange. We're going to add 5 more mils for good measure, our purple compound has completely been converted back to the orange material. If we wait just a minute, we're going to find that this material is completely insoluble in the aqueous layer, just as we found before, and we will see that it is beginning to precipitate out. And so you can look, if you look carefully, you'll see that the solid particle is precipitated out in solution. If we wanted to, we could extract this solution back into ethyl acetate and we would recover it in ethyl acetate. Converting a compound into its salt form is an excellent way of separating out organic compounds based on their pKa's.